This lesson will cover translations. The learning goal is to explore the effects of translations on the equation of a function and its graph. Your success criteria is you can describe the transformations of a function based on its equation or graph, and you can create a graph of a transform function. So we now know the parent function with transformations of this form, which we call the general equation. From the general equation, a variable d represents the horizontal translation, and variable c represents the vertical translation. Again, we have to remember that horizontal transformations will have the opposite effect on them. So if d is positive, it's going to move left, and if it's negative, it's going to move right. Now again, there are several ways of graphical function transformations, and we'll be using the table of values of the parent function to do this. So graphical function of the form y equals f of x plus c, we have a parent function of f of absolute value of x. So getting the table of values right, we have x and y equals absolute value of x. We have our key points of -1, -2, -1, 0, 1, and 2. Remember, absolute value takes whatever's inside of it and outputs a positive version of that value, or really the magnitude, the size of that value. So absolute value of -2 is 2 itself, -1 is 1, absolute value of 0, 1, and 2 are these values is already positive. And let's plot our parent function here. So we have 0, 0, 1, 1, 2, 2, -1, 1, and -2, 2. And now we're going to look at g of x here. So let's change colors and let's look at the translation of this. So this is g of x equals absolute value of x minus 2. So this is the c value. This right here, this is a vertical translation. And if it's addition, it's going to move up. If it's subtraction, it's going to move down. So here our x values are going to remain the same. So you have -1, -2, -1, 0, 1, and 2, and our y values, we're going to subtract 2 from them to get our transform points. So 2 minus 2, that's 0, 1 minus 2 is -1, 0 minus -2, minus 2 is -2, 1 minus 2 is -1, and then we have 0 again. So plotting these points, we have -2, 0, we have -1, -1, and we have 0, -2, and we have 1, -1, and 2, 0. So here we've shifted the whole function down by 2 units. All the coordinates have been moved down by 2. And now we have h of x equals absolute value of x plus 3. So let's get this in here. X values remain the same. We have -2, -1, 0, 1, and 2. And we're going to add 3 to our y values this time. So from the parent function, we're going to take these values here. We're going to add 3 to all of our y values. So 2 plus 3, that gives us 5. 2 plus 3, that's 4. 0 plus 3 is 3. And we have 4. So adding 3 to each of these coordinates, we have 0, 3, 1, 5, 4, and -2, 5. Our points, and make sure we have the arrows on here to show that we're moved off to infinity. And the next, we're going to be looking at horizontal translations here. So here we're going to be sketching using x squared as our parent function. So let's get our table of values of it. So we have, again, our initial points of -2, -1, 0, 1, and 2. And our y values are equal to x squared. So -2 squared is 4. And then we have 1, 0, 1, and 4. Plotting these points for our parent function. And connecting them. We now have x squared. And at this time, we're going to be taking our points, and we're just going to move them from the graph themselves. So let's look at g of x here. So g of x is x plus 2. So this right here, this is a translation to left. So we're going to take each of our coordinates, we're going to move them all left by 2 units. So at 0, you go 1, 2. So here is our new point at -1, 1. We can move this to left, so 1, 2. At 1, 1, moving to left, we have 1, 2. It has the same position as the point we already have. 2, 4, moving 2 units to left, we have 1, 2. And then -2, 4, we go 1, 2 to left. Connect points. And we have our transform function. And then let's look at h of x equals x minus 3 squared. 1 minute here. My OneNote has decided to stop working here. For h of x, we're going to set up a table of values. So our y values stay exactly the same. We have no transformations on y, so we have 4, 1, 0, 1, and 4. But our x values, there's going to be x plus 3, because here this is a translation of 3 to the right, so we have to move our x values 3 to the right. So negative 2 plus 3, that's 1. Negative 1 plus 3, that's 2. Then we have 3, 4, and 5. So let's plot these points. We have 1, 4, 2, 1, 3, 0, 4, 1, and 5, 4. So that is h of x being translated 3 to the right. So again, with horizontal translations, you're looking at the value affecting x, and you're going to do the opposite of that. So kind of think about it like this thing. You can write it as like my new x, or we say like x new minus 3, what we have here, equals x old, and then we are going to solve by adding that 3 over. And that kind of tells you what operation you're going to be doing and what you should be doing for your table of values. So in summary, the C value is going to be vertical translation. If C is positive, graph moves up. If C is negative, graph moves down. D is the horizontal translation. If D is positive, the equation will look like x minus D. The graph is going to move right. If D is negative, the equation will look like x plus D. The graph is move left. Because if D is negative, it would be x minus negative D, and that would be x plus D. That's where this is coming from. And that's just due to the form of the equation being x minus d originally. So let's have a look at this example where we have a given function again, and we're going to sketch f of x minus 1 plus 2. So we have two translations, sorry. We have translation to up, and we have translation 1 to the right. So we'll take each of these points and we're going to move them 1 to the right and 2 up. So 1 right, 2 up, 1 right, 2 up. And there's nothing fancy doing here. You're just shifting these points over due to our translations, just kind of like you did way back when you're learning translations back in like grade 6 or 5. Nothing fancy going on here. You just connect your dots. And that is our transform function.